your lab a little bit yesterday. So yesterday, once again, we had dialysis tubing. And your dialysis tubing, although it looked to be solid plastic, I think is an okay term to use, there was again little tiny holes in the membrane. So even when you rinsed it and before you put it in the beaker, it wasn't going drip, 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 drip. Okay? Because the holes are small, but they are there. So we immersed this dialysis tubing in a beaker of water. And in the beaker we had water and we had iodine. I believe it's I2. Yeah, it's I2. And inside our dialysis tubing we had water, we had starch, and we had salt. Okay? Now, what's going on with all of those molecules is a mosh pit. Okay? They're all going, you can't hear it. Biology! Okay, that's what they're all doing. Okay, it's called the kinetic molecular theory. All molecules are in constant random motion. As you increase temperature, generally speaking, you increase the kinetic energy of said molecule. So realize that these things are going this way, they're going this way, they're going this way, they're going every which direction. Sometimes they will hit the wall and bounce back. Sometimes they'll hit another molecule and bounce back. But sometimes they line up such that they go whee right through the doorway. Okay? And they're in constant random motion. Now, we did some tests. We did a test yesterday for starch, and we did a test for salt. So by putting the iodine here, what we were able to see is whether the starch came out of the membrane, because if they did, it would turn color, it would turn that purple-black color. So if starch comes in contact with iodine, it would turn purple or black. Okay, so if on the outside we had purple, that means the starch came out. By using iodine on the outside, we were also able to look to see if iodine went into our cell, because if iodine went into the cell, it would bind with starch and turn purple or black. We did a salt test, and what we were able to do is drip silver nitrate, and we put it in this beaker of water. And our beaker water was distilled water and distilled water only with iodine. And a negative test of silver nitrate was clear, and if it turned like a chalky, cloudy precipitate, it like form a solid chunks, then that was a positive test. So based upon those tests, and that's what that first data table showed you, we were able to figure out whether things entered or left the cell. Those molecules entered or left the cell. How were we able to tell whether water entered or left the cell? What was the first thing you did before you soaked it? You found the mass. And what was one of the first things you did after you soaked it? You found the mass. Okay? Now, if it gained mass, there's a couple things that could have happened. It could have gained water, and it could have gained iodine. Of those two in that beaker, what was there more of, water or iodine?
Water.
Way more, right? We did like a squirt of iodine versus like 100 milliliters of water.
2 squirts of iodine.
2 squirts, you're right, 2 squirts of iodine. Generally, like overall though, way more water. So could iodine have contributed to a mass gain? Yeah, but in significance, probably fairly insignificant compared to the water because of the pure volume of water we get. Now, if your cell lost mass, that could be contributed to 3 things. That the salt came out, the starch came out, and or the water came out. Okay, so those are all things that would affect the mass of the cell. This is a lot like This is a lot like this, right? So our dialysis tubing has little tiny holes, much like this sifter does. Okay, some of them fit through, some of them get left behind. And based upon our test, we can make some observations and conclusions on that. Now, one thing I did is I left mine that I set up for you yesterday. So all night long. What color was your beaker water when you were done?
Yellow. Like golden yellow.
Get golden yellow.
Wow.
Okay, so there's still a little bit of yellow in there, right? You still kind of see a little bit. But what's true about the color of this beaker water compared to your beaker water?
It's more clear
It's more clear. Why?
because it was left out overnight.
Okay, so why would that make it more clear though?
So you had more time to soak into the artificial soil.
What had more time to soak into the artificial?
So that iodine.
The iodine, right? But what about equilibrium? Shouldn't we have reached equilibrium and then it should just like stop, right? Or at equilibrium, does the party stop?
No.
No, right? The mosh pit's still going on both sides. So what should happen is that iodine should be flowing in and it should be flowing out at an equal rate. However, notice the color of my artificial cell.
It's also transparent.
Okay, but fairly, in terms of starch, turned very purple, right? You ever heard of a one-way valve?
Yeah.
What's a one-way valve do?
Let stuff out, but not let stuff in.
Right, it lets things go in one direction. You see it in like a plumbing sometimes, a check valve they call it. And if you're on city water, it's called a pressure regulator or something or other. And it's where your main water comes in. There's a series of valves, but there's this thing. It's brass generally. And what it does is allows water to come in. It affects how much pressure you have going to your shower and everything. If you have too much, that's bad. If you have too little, that's also not great because then you're like standing under dripping shower heads, right? But what that also prevents is a one-way valve system. Because in the event that something happened in your plumbing system, we don't want to take contaminated water from your house and start putting it back into the village lines to affect the next person, the next person, the next person. That's kind of what's going on here. Kind of. It's not really a one-way valve. But what happens is the iodine went in and it chemically bonded, I think it was a chemical bond, to the starch, and now that's attached to the starch. Did the starch ever come out of your cell?
No.
Did we get a positive test for starch on the outside or no?
No.
No, right? So what's true about the starch molecules? They were kind of like the chocolate chips, right?
Yeah.
So what happened is, what's on some of these chocolate chips right now? There's some flour. Why? Because some flour stuck to the chocolate chip. And it's on there, and none fell off. Okay? That's kind of what happens. That iodine went through, and it stuck on, and now it's part of that starch. In diffusion, our mosh pit analogy, right? When we had 24 and 2, which direction did most people flow? From the hallway in, or did Mr. and DeBoer and I diffuse outwards?
Hallway in.
Hallway in, right? Because the concentration was higher on the outside than it was on the inside. Once we got to say 20 to 6, or 15, well, whatever, 11, I think it'd be 15, 11. Okay, there were still more people outside. There's still a higher concentration outside. But did some people, constant random motion, randomly on the inside, line up just perfect to go back out in the hallway?
Yes.
Right, they're still doing a mosh pit inside. On average, what's true about the amount of people coming in compared to going out? 15 to 11, which direction were they still generally flowing? In, there were more people coming in, but were some going out? Yeah, some were still going out. On average, more were coming in. On average. It's kind of what's going on with that iodine. Okay, so even though we reached equilibrium, even at equilibrium, the party's not over but on average, the amount going out equals the amount going in. In that beaker, the iodine still would randomly go in, even if the concentration of iodine becomes lower on the outside, it's still lining up, and it still might hit that hole in the dialysis tubing. But what happens once it hits the starch is it's now stuck, and it's stuck in there, which contributes to why it's clear. Okay, mosh pit, I like it. I use it a lot because I think it fits really well as an analogy. Okay. So, things to do, I think Mr. DeBoer kind of ran through this already with you. Artificial Cell Lab, there's some questions for you to answer, some observations. The very last question talks about physical size, list from biggest to smallest, a physical size of like water, salt, starch, and then the holes in the dialysis tubing themselves, I believe is on that list. There is that beaker sheet, the hypertonic, hypotonic, isotonic sheet. That we did the first 2 or 3, depending on which hour you're in watching this video. We did 2 together. These are things you should be able to do. We might go through a couple of those yet today before we walk out of here. On Monday, after your quiz, there was the POGO membrane structure and function thing that some of you finished, some of you have not finished. And then other missing stuff. Okay, so we've been talking about when we're going to test on this. We're not done. There's still one more section. We have a lab that we're going to do next week, Tuesday, Wednesday. We have a 3-day week next week. You're aware of that, right? Okay, 3-day week, Monday, Tuesday, Wednesday. The following Friday, so 2 weeks from today, is the end of the quarter. So we're looking to test about Tuesday or Wednesday of the following week. That's today. Today's the 22nd. So we're talking like the 2nd or 3rd, somewhere in that ballpark is probably where we're going to be testing, because the quarter ends on the 5th. Okay, so just kind of mentally be thinking about that. We'll have some review stuff like we did last time to try to help you prepare for that, but kind of keep that in the back of your mind.
Do you find that pretty useful? I mean, you seem pretty engaged in the Kahoot. Or not, yeah. Quiz,
We should.
live, yeah. Quiz with live, sorry. Did you, pretty useful? I mean, okay. I'm just curious to get feedback on that.
Okay, so you have some time. We may go through a couple of those of number 2 together, just to kind of make sure you're all on the right page, because that is something we expect you to be able to do. So.